Is it recording, guys? Do you see the timer? All right, so we're just gonna go for it. So right now, you guys should be on page 7 of your math notes. For those of you watching this video, I am recording in one of my classes, so you might hear students respond to some of my questions. You can also respond to the questions. So page 7 of your math notebook, please title it Outliers. We're gonna get in depth into outliers. So before, I just taught you what outliers were. Outliers is just a number that doesn't look like it belongs with the rest of the set. So if you think about a number, like a set of numbers like 1, 1, 1, 2, 2, and then you have a random 15 in the list. 15 would be considered your outlier. So the 7th grade level is just kind of for you to be familiar with the term outliers and to recognize them just by the naked eye. But now at the 10th grade level, at the statistics level, you're going to be able to distinguish an outlier mathematically and also tell how the outlier is going to affect your entire set. So let's start. Outliers can skew or change the shape of your data. You should have written that already. Outliers can skew or change the shape of your data. So if you think about an outlier, something is going to stay the same in terms of mode, mean, and median. Which one do you guys think is going to stay the same? Mode, mean, or median? Think about our sample. 1, 1, 1, 2, 2, 15. What do you think will not change? Go ahead. Yeah, the mode doesn't change. So go ahead and write down the mode. Can you guys see this color? Yeah? Okay, so the mode will stay the same. An outlier is not going to change the mode. But an outlier is going to change the median a little bit. So the median, you should be writing this down. The median will change a little bit. And what's left is the mean. And the mean will change significantly if we have an outlier. Okay, now I want you to think about it. If you have a really low outlier, so let's change our list. Let's say we have 100, 100, 100, 200, 200. That's a big, change to what we had originally. So let's say we had 100, 100, 100, 200, 200, and then we had 500. Do you guys see how that outlier would be really high? Yes? So if the outlier is really high, that means the median will increase and the mean is also going to increase if you have a high outlier. So inside here, you're going to write the median will increase a little bit. So the median is going to increase a little if you have a really high outlier. And the same thing will happen for the mean. So the mean will increase with the high. I honestly think that the mean will increase more than a little bit, but we're just going to write a little bit because it just depends on the case. So in the same way, what if I had a list of numbers and then I had a really low outlier? What do you think will happen to the median? Is it going to increase or decrease if you have a really low outlier? I heard it. Yeah, it's going to decrease. So the median, if you have a really low outlier, the median will decrease a little bit. And then if you have the mean of a set with a low outlier, it's going to also will decrease. Sorry, my writing is a little sloppy. It'll get better. I'm not used to the e-glass. I am used to the e-glass, but I haven't used it that much recently. It's super sloppy. Okay, so here's the conclusion. You guys can write conclusion underneath your chart on your paper. I just ran out of room. Here's the main conclusion. Since the mean can be heavily affected by outliers, if you do have an outlier, the better measure of center would be a median. So let's say they're asking you like what the average is or what the median is or what the overline trend is. You want to look at median if you have an outlier. If you don't have an outlier, go with mean, go with the average, okay? So we're just going to write that into words. So since mean, or since the mean, is heavily impacted by outliers, it is best to use median if a data set has outliers. So if, sorry, no comma there. If a data set has outliers. Okay, I'm going to give you guys a second video to outliers. This is just the first one, the beginning. Okay, so now we're going to do part 2 of our outliers. You guys can draw a line or just say outliers continued on your notes. And we are actually going to talk about the math formulas for calculating lower and upper outliers. So write math formulas. Can you guys see this color? Yeah? So math formulas for calculating lower and upper quartiles. Sorry, not quartiles, outliers. So if we're trying to calculate for a lower outlier, and you can do both. So if you're trying to do a lower outlier, can you guys see that color? No? Or you can? Is it fine? Lower outlier. It would have to be less than quarter 1 or quartile 1 minus 1.5 times interquartile range. And then if you guys remember, the way you find interquartile range, I'm going to put it on the side. Interquartile range. Does anyone remember how you find interquartile range? Say it out loud. Q3 minus Q1. All right, so that's if we're calculating for a lower outlier. Now let's see how we would calculate for an upper outlier. So for an upper outlier, it would have to be greater than quarter 3 plus 1.5 times interquartile range. Okay, now I'm going to show the class. I'm going to show you guys a 2-minute video from YouTube. And then we're going to come back here to our e-glass, and I'm going to explain the example from the video in my way. Okay? Okay, I think it's recording. So you should have already seen the example in the YouTube video. I just copied the example here, and I'm going to go over it a little slower. So here's the list of text messages a group of teenagers sent. We can clearly kind of guesstimate that 100 is the outlier, but we're actually going to prove it mathematically using these formulas that I gave you earlier. So in this list, we have to find first our median, our quartile 1, quartile 3, our min, and our max. Now our minimum is 0, our max is 100. The median is the number that's in the middle of all these numbers when they're in order from least to greatest. So we would eliminate 100, 0, 58, 1, 40, 1, 32, 2, 26, 3, and it looks like we have 5 and 18 in the middle. So we add those two together and divide it by 2. 5 plus 18 is 23. 23 divided by 2 is 11.5. So our median is 11.5. So I'm going to put 11.5. That doesn't mean that it's included in the list. I'm just saying like my median is right there. Now I already know that this is my min and this is my max. Now in order to find Q1, you don't start from the median, you start from the number after the median or before the median. So we're going to do from 0 to 5. So find the median, cross out, cross out, cross out, cross out, and it looks like you're left between 1 and 2. So you can add those, which is 3 divided by 2, and that's 1.5. So 1.5 is my quartile 1 or my Q1, 1.5. Let me rewrite that. And then same thing over here, you don't use the median, you start with the number above it or right next to it. So I block 18 and 100, 26 and 58, 32 and 40 are in the center. 32 plus 40 is 72. 72 divided by 2 is 36, which we have here for our quarter 3 or our quartile 3. The next step after you find min, max, Q1, Q3, and the median is you find interquartile range. And if you guys remember, interquartile range are the numbers between the range within the box plot. So that's going to be Q3 minus Q1. And in our case, we have 36 minus 1.5, which is 34.5. So now that we have interquartile range, we're going to plug this number into our formulas. We're going to get our Q1, 1.5, and our Q3 and plug it into the formula. So I'm going to write this underneath. So let's look if we have a lower outlier. That means that the lower outlier is going to be a number less than Q1, which is 1.5, minus 1.5 times 34.5. So again, all I did is I substituted my quarter 1, which is 1.5, minus 1.5 times the interquartile range. And then if I'm looking for an upper outlier, can you guys see this color? Okay, if I'm looking for an upper outlier, it has to be a number greater than Q3, which is 36, plus 1.5 times the interquartile range of 34.5. Now, if you guys notice, 1.5 times 34.5 is there. 1.5 times 34.5 is there. So if you put these numbers into a calculator and you multiply them, you get 51.75. So this number is 51.75, and this number is also 51.75. So in a way, you can do both of these formulas in 2 steps instead of multiple steps. You can just get interquartile range times 1.5 and then take 1.5 away from it. You just got to be careful with that negative. And then in the next step, add 36 to it, or Q3, and you'll see what the limit is. So 1.5 minus 51.75 is, so for the lower outlier, sorry, I'm kind of out of breath. 1.5 minus 51.75 is negative 50.25. Do we have any negative numbers here? Any negative lower outliers? Can we have a negative amount of text messages? No. So our lower bound, it's not really needed in this context. But if we had a negative number, like if we had negative 60 in the list, we just proved that it's an outlier because it's not within the boundary. Let's go to upper. This is the one that we really care about. 51.75 plus 36, I believe it was 87.75. Is there a number that's greater than 87.75? Yeah, 100. 100 is actually greater than 87.75. So we just proved that 100 is actually an outlier because it's greater than the bound. So if we were to graph this, we would end up having like a box plot that looks like this. And then we'd have a boundary of like 87.75, and then 100 would be outside of that boundary. So this is how you would plot 100. You would do your box plot excluding 100, and then on 100 you would just put an X to tell you that you do have an outlier outside your boundary. So if you guys ever see a picture like this, and you see a boundary, and it tells you what does this number represent, what does that number represent? An outlier. Yeah, an outlier. Now, does it represent a lower or an upper outlier? An upper. And if you had a boundary line over here and you had an X out here, that would be a lower outlier. Yeah. Good job.